Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about our review for our upcoming test that we have coming up over Module 4. So these are some sample questions similar to what you will see on the test. So I'm just trying to get you in the best position to be successful in this upcoming test. So let's go ahead and get started. Let's look at this following question here. We want to graph negative 2x plus 4. Now we've been working in our Desmos calculator for quite some time. So really all you have to do is graph this in your Desmos calculator, and I would just advise you to identify your x-intercept and your y-intercept, and then you want to go ahead and plot your points. And so if you do that, then this is what your graph looks like here. And notice your x-intercept is going to be 4, so it's going to cross the y-axis at 4. All right, and then your y-intercept is at 2. All right, and then you connect those 2 points together. All right, it's a negative slope, so it's going to decrease. All right, and so your graph will look something like this. So this is the graphical representation of negative 2x plus 4. All right, let's take a look at this one. Same thing as we did in the previous question, but there's something that's different. Number one, this is not in slope-intercept form. This is in standard form. And then we're still looking for our x and y intercepts. You can approach this one of two ways. Well, you can approach this several different ways. We could type this in Desmos, and it'll graph it for you. Just identify your x and your y intercepts, plot them together, and connect it. You could rewrite this in slope-intercept form, and then you could graph it that way. Or you could just find your x and y intercepts by substituting. For example, to find my x-intercept, substitute 0 for y. So then 2x plus 4 times 0 equals 8, which will be 2x equals 8, and x will equal to 4. So your x-intercept will be 4. So when y is 0, x will be 4. All right, and then the other way around, substitute 0 for x to find your y-intercept. So 2 times 0 plus 4y equals 8. 2 times 0 is 0, so leaving you with 4y equals 8, and y will equal to 2. So your y-intercept will be 2. So when x is 0, y is 2. So your x-intercept is 4, your y-intercept is 2. You connect those two together. It will be a negative slope. All right, so your graph will look something like this. All right, let's look at this. Y equals negative 5. Notice, think about the slope-intercept form. Y equals mx plus b. All right, there's no slope here. All right, you only have your y-intercept, which is negative 5. So if there's no slope, meaning your slope is 0, you're going to have a horizontal line at negative 5. Even if you plug that in your Desmos, y equals negative 5, you have a horizontal line at negative 5. Let's take a look here. In 2018, Marcus spent $1,200 on gym memberships. In 2021, he spent $600. What was the rate of change spending from 2018 to 2021? What I want you to notice, first of all, is look at it. When he first started, he spent $1,200, and then in 2021, he spent $600. There's a decrease. All right, and so we're looking at the rate of change. We're looking at the fact that since it's a decrease, your rate of change should be negative. So we already know we're going to eliminate B and D already. All right, so we got to find our rate of change. So what we need to do is we got to find the difference. All right, so let's take a look here. We want to find the difference. 1,200 minus 600 is a difference of $600. But since we said it's going to be a difference, it's a decrease. It's going to be a negative 600. Now, look at it. So we're looking at per year. All right, look at the decrease in memberships per year. That's what we're looking at, the rate of change. All right, because you're comparing two different units. You're comparing the cost versus the year. And so since 2018 to 2021, all right, there is a total of 3 years. So what we want to do is we want to take this negative 600 and divide it by 3. And we take the negative 600 divided by 3, that is a decrease of $200 per year. So A would be the answer, assuming that the rate stays the same as far as the level of increase. Let's look at number 5. What is the slope of the line that passes through 5, 7, and 11, 4? You can do a couple of things here. You can apply the slope formula. Slope formula is saying I'm going to take my y2 minus y1 and divide it by my x2 minus x1. So this is x1, this is y1, x2, y2. So I'm going to do 4 minus 7 over 11 minus 5. that's going to give you a negative 3 over 6, which gives you negative 1/2. All right. Another way you can find this out, you can go ahead and put these two in your Desmos as a table. All right. Put those order pairs in, 5, 7, and 11, 4, and it creates a regression. And when you do that, notice what happens. This is your equation that comes up, and then look at the slope. The slope is negative 0.5, which is equivalent to negative 1/2. So your answer would be A, negative 1/2. All right, let's look at the next one. True or false? Of arithmetic sequence, I say arithmetic, but arithmetic sequence must have a constant difference between consecutive terms. In order to make an arithmetic sequence, or what makes a sequence an arithmetic sequence, is what you call a common difference, meaning you're going to add or subtract by the same number for each term in your sequence. So if we go to the statement, we must have a constant difference, which is the same thing as saying your common difference. That's going to be true. All right, let's look at number 7. What is the slope of the line that passes through these points? Similar to question 5. All right, you can do your slope formula. Y2 minus Y1 over X2 minus X1. So negative 3 minus 7 over 5 minus 5. Look at negative 3 minus 7. That's going to give you negative 10. 5 minus 5 give you 0. But look, I have a 0 in my denominator. Anytime you have 0 in your denominator, you're going to have undefined. It's going to be undefined. We could plug this another way. We put these points as a table in our Desmos and add our regression. All right, once we do that, notice, yes, it gives a slope here, but look at here. R is undefined. We don't know what R is. All right, R, which is our slope. We don't know what the slope is. All right, and so therefore your answer is going to be C, undefined. Let's take a look at number 8. Which of the following sequences is arithmetic sequence? Go back to the previous question on question 6. We said an arithmetic sequence has to have a common difference. So whichever has a common difference, meaning whatever I need to add by the same number or subtract by the same number, that's going to be arithmetic sequence. Look at number 2. I'm adding 3. All right. I'm adding 3. I'm adding 3. A looks like an arithmetic sequence. Look at B. I'm adding 10, but then I'm adding 20, but then I'm adding 40. We're not have a common difference here, so B won't work. If you look at C, I'm decreasing by 4. I'm decreasing by 4. I'm decreasing by 4. So C looks like that'll work. Let's look at D. Look at what's happening. I'm increasing by 3, but then I'm increasing by 5, and then I'm increasing by 7. So D won't work. Then look at E. I'm decreasing by 10. I'm decreasing by 9, and then I'm decreasing by 8. That doesn't work. So your answers here, all right, which would be A and C. A and C will work. All right. Let's look at number 9. The table shows the relationship between X and Y. Complete the statement. So we want to determine whether or not this is a linear function or not. This function describes the relationship between X and Y. That's what we're looking at. Is it linear or nonlinear? Well, it looks like we have the same rate of change. All right. We got the same rate here. So it's going to be linear. Why is it linear? Because for each 2 for your X, so look at what's happening to X. My X, I'm increasing by 2 each time. All right, look at your Y. What am I doing each time? I'm increasing by 4. So when X increased by 2, Y increased by 4, 2/4, which is equivalent, all right, to 1/2. Well, increase by 2, increase by 4, I'm sorry. 4 over 2, which is 2. All right. But look at what's happening. I'm increasing by 4 each time. I'm increasing by 2 each time. So each time X increases by 2, Y increases by 4. So that's what will be your answers for this particular question. So just look at the relationship between X and Y. Look at what X is doing, and look at what Y is doing. And is it constant for each one? Okay. All right, let's look at number 10. A rental company charges a one-time fee to rent a car plus a fixed cost per miles driven. And this is given by this function, y equals 0.75x plus 20. Notice this is a slope-intercept form. So if we look at the slope-intercept form, we're trying to determine what represents the one-time fee. Think about it. Your rate of change represents the rate at which something increases or decreases. Is something per, is 1 unit per another unit, whether it's cost per mile in this instance, miles per gallon, whatever the instance is, that per is a key word that lets you know that you're doing rate of change of slope. Your y-intercept is your one-time fee, which you beginning when you started something that's a cost, that's a one-time cost that's going to stay the same in your equation. And so if you look, that one-time fee, that's going to be your y-intercept, because look, let's say that you drive no miles, you're paying $20, all right? So $20 is your beginning cost. So the one-time fee would be the y-intercept. That would be the $20. So $20 would represent the one-time fee. All right. Let's look at number 11 here. All right. A car rental company charges a one-time fee. This is the same question, but look at, well, this is a similar question, but look at the difference. We're looking at the cost per mile. Now we're looking at the cost per mile. We're not looking at the one-time fee, looking at cost per mile. So if 20 was the one-time fee, the cost per mile, which is your rate of change, would be 0.75. So 0.75 or 75 cents would be the cost per mile, which is your rate of change. All right, let's look at number 12. Let's rewrite this to slope-intercept form. You can do this a couple ways. All right, we can apply the concept of linear equation. We apply the concept of linear equation. What we're doing is we're trying to rearrange this equation so that y is all by itself. So how do we do that? We first take 6x, subtract 6x on both sides. That's going to give you negative 2y equals negative 6x minus 12, because they're not like terms, so you can't combine them. All right. And so now I need to get y by itself. How do I do that? Divide both sides by negative 2. All right. Once I do that, negative 6 divided by negative 2 is positive 3. And negative 12 divided by negative 2 is positive 6. So y equals 3x plus 6. That's one way we could do it. Another way you could do it, you can use your decimals to help you. Go ahead and do your 6x minus 2y equals negative 12. Graph that, be able to identify your x and your y-intercepts. Your x-intercept is negative 2 and 0. Your y-intercept is 0 and 6. When you add your table, put your x and y-intercepts in, and add your regression, look at your equation. All right, it gives you the same equation here. All right, so then we can fill this in. So our rate of change is 3, and then our y-intercept is 6. So y equals 3x plus 6. All right, let's look at number 13. Let's write an equation for the nth term. So we got to write an explicit formula. The first thing we got to do, we got to identify our common difference. Our common difference is negative 3. All right, minus 3. What's the first term in the sequence? That's 12. All right, and so we got to use this here. So our explicit formula is the first term of the sequence, which is a subscript 1 plus the common difference times n minus 1. That's just a formula that we got to know, and you have that. All right, so the first term is 12. So 12 minus 3 times n minus 1, because your common difference is negative 3. And then what we want to do first, do your distributive property, negative 3 times n, negative 3 times negative 1. When we do that, negative 3 times n is negative 3n, negative 3 times 1 is 3. All right, and then after we do that, we combine our like terms, which is 12 and 3, because they're both constants, and that's going to give you 15. So negative 3n plus 15, that is your explicit formula, all right, for the arithmetic sequence. And so that will be our answer. How do we know that? If we substitute the first term, because n represents the term, negative 3 times 1 is negative 3. Negative 3 plus 15 is 12. If we do 2, negative 3 times 2 is negative 6. Negative 6 plus 15 is 9, and so forth. All right. Let's look at number 4. Number 4 says a gym starts the year with 250 active members. Each month, about 15 members cancel their membership. Write an equation of slope-intercept form that represents the number of active members after X months. So think about the slope-intercept form. Is y equals mx plus b. All right. We start the year with 250 members. Remember, your y-intercept represents your beginning value, which is 250 in this case. And then your rate of change is at what rate is going to increase or decrease. And so each month is 15 members cancel their membership. So 15 members per month cancel their membership. So if you're canceling, you're subtracting. So it's going to be y equals 250 minus 15x, or negative 15x plus 250. And then last one, what we want to do to solve this here, we just want to rewrite this as slope-intercept form. How do we do that? We divide both sides by 2, and we get this is our slope-intercept form. This represents our y-intercept, and this is what it's asking for the y-intercept, and we get 1,222,800.